we have seen that carbonyl compounds with an alpha hydrogen can give the corresponding enolate if they are treated with catalytic base, and that enolate can undergo then reaction with an aldehyde or a ketone in nucleophilic addition reaction type to give beta hydroxycarbonyl compounds. And of course, the beta hydroxycarbonyl compound can undergo elimination reaction with the action of catalytic base in E1CB type mechanism. Now, the Aldol reaction can also take place if both aldehydes or both ketones are present in the same molecule. So, for example, a diketone. Let's take an example, something like 1,4-diketone. This is a 1,4-diketone. Look, 1, 2, 3, 4. It's a 1,4-diketone. Now, if the 1,4-diketone is treated with catalytic sodium ethoxide, for example, this catalytic amount of the base should be able to deprotonate one of the ketones at the alpha position to make the corresponding enolate, and that enolate should react with the other ketone. For example, if an enolate is formed here, and that enolate should attack this ketone in an Aldol reaction. But this Aldol reaction would be very unique because both functional groups are actually present in the same molecule. So this reaction should be called intramolecular Aldol reaction. So the product that's obtained is actually this. It's an alpha beta unsaturated carbonyl compound. We can actually number these carbon atoms like this: 1, 2, 3, 4, 5, 6. So if the catalytic base makes an enolate, let's say from the alpha ketone, so this enolate is then obtained. Again, we keep track of carbon atoms by numbering them. So now the enolate should attack, the enolate that is formed should undergo nucleophilic addition type or Aldol reaction on the other ketone. So the new bond will be between carbon number 1 and carbon number 5. So this should be 1, 2, 3, 4, 5, and obviously 6. Initially, a beta alkoxy carbonyl compound is obtained. Again, these are the numbers 1, 2, 3, 4, 5, 6, and of course this beta alkoxy carbonyl compound undergoes a protonation with ethanol again, because ethanol is produced to give beta hydroxy carbonyl compound. So 1, 2, 3, 4, 5, 6. But we learned before that beta hydroxycarbonyl compounds undergo elimination reactions with catalytic base to give the corresponding alpha beta unsaturated carbonyl compound. So this is the final product, and this reaction is called intramolecular Aldol reaction. So an intramolecular Aldol reaction takes place if there is a 1,4-diketone, and if that 1,4-diketone is treated with catalytic amount of a base. The catalytic amount of a base should make an enolate of one of the ketones, and that enolate attacks the other ketone in nucleophilic addition in Aldol reaction. In this case, of course, it is called then, because the enolate attacks the ketone within the same molecule, so therefore it is called intramolecular Aldol reaction. The initial beta alkoxy carbonyl compound undergoes protonation to give beta hydroxy carbonyl compound, which in turn undergoes elimination reaction to give eventually alpha beta unsaturated carbonyl compound. So an intramolecular aldol reaction can take place if there is 1,4-diketone, and if that 1,4-diketone is treated with catalytic amount of a base to give a cycle. It's actually a 5-membered ring. It's also an enone because there is a double bond, of course, and a ketone. It's called an enone. It's an alpha-beta unsaturated carbonyl compound. The ring size is 5. So it should be an important reaction in synthesis.